In this video, we're going to discuss a trend that is based on ions, okay? So it's important that we now understand what an ion is so that we can understand the trend that is ionization energy. Ionization energy is the energy to remove an electron from an atom. The first ionization energy is how much energy it takes to remove the first electron. The second ionization energy is to remove the second. And the third ionization energy is how much it takes to remove the third electron. And the third ionization energy is always greater than the second, which is always greater than the first. So you might see a table like this. Basically what this table shows, is even though there's no units here, is these values represent kilojoules, and joules, remember, is the unit for energy. So hydrogen has one electron in its outermost shell, so it only has one ionization energy, the first ionization energy, and it's relatively high. It doesn't want to lose that electron. Okay, now if we look in general, if we look across each one of these rows, you can see that the first row is less than the second and the third for all of them. Okay, now, if we look specifically at lithium, for example, now lithium only has one electron in its outermost shell. Remember, it has 3 electrons total, so 2 in the first shell, which is full and happy, and then the third shell just has 1. It tends to want to lose 1 electron. It takes very little energy for it to remove that first electron, but then when we get to the second and the third electron, the energy is very high because we're trying to pull it out of an energy level that is full and happy with its full number of electrons. Okay, so it's important that you can sort of look and sort of interpret what these numbers mean, but for the most part primarily recognize that it takes more energy for them to remove electrons, more and more electrons, as we go further away. So first ionization energy is less than second, which is less than third. Now, let's talk about the trends within the periodic table. So remember, as we go down a group in the periodic table, the trend is based on the number of energy levels. As we go down a group, the first ionization energy decreases. And the reason is because the outer electron, or the first electron that is going to leave, gets further and further away from the pole of the nucleus. And electrical attraction is just like magnets, is based on 2 things. It's based on the strength of the charge, but also the proximity of the charges to one another. So if an electron is further away, the hold that that nucleus has on it is a lot weaker, is a lot less. And so it takes less energy to pull it away. So as we go down the periodic table, or down a group in the periodic table, the first ionization energy decreases. Now, the periodic trend, the trend across the periodic table. Remember that all of the atoms in that same period have exactly the same number of energy levels. But as we go across, we have more and more protons. So the strength of the charge and the pull of the nucleus on the electrons becomes greater and greater and greater. Therefore, the ionization energy, or the energy to pull an electron away, increases from left to right because the nucleus sort of gets bigger and stronger and holds on tighter and tighter, and therefore it takes more energy to pull it away. And that's why as you go across the periodic table to the nonmetals, we're a lot less likely to have electrons be pulled away, right? Nonmetals tend to want to pull electrons to themselves rather than give up electrons. So just keep in mind the driving forces, the nuclear charge, as well as the proximity of the electrons to the nucleus, or the number of energy levels. Okay. Now I want to point something out here. Really, what every atom is trying to do is it's trying to act like a noble gas. It wants to achieve a noble gas configuration. It wants to have its S and P levels full. Okay, so keep that in mind, that it's tending to want to either lose or gain electrons to have a noble gas configuration. Now on your periodic table, I want you to draw this in there. I want you to note that The ionization energy generally decreases as we go down a group as a result of the increasing energy level and the distance of the electron from the nucleus, as well as the energy generally increasing, or the ionization energy generally increasing as we go to the right because of the nuclear charge, the increase of the number of protons, and the strength of the nucleus to hold on to those protons or those electrons.